Datera delivers high-performance data orchestration and advanced automation to large enterprises and cloud service providers, reducing storage management and infrastructure costs by as much as 70%.
Today we will cover stretch clusters, and we're going to provide an example of how it helps Datera customers in the real world improve their data availability, and more importantly, how simply stretch clusters fit in with the overall power and flexibility of Datera's data services platform. So first, let me define a few terms. The first one, software-defined storage, or SDS. This is the ability to use off-the-shelf or branded commodity storage servers, lets you serve all your persistent storage needs. Fault domains. Stretch clusters use fault domains. Fault domains can be a different rack, different data centers, or even completely different sites. It's used to achieve storage high availability. Typically, any server or VM in a common fault domain will share network and power. If there's a failure in a fault domain, then all of the resources in that fault domain become unavailable. Cabal members. This is a select set of nodes within a cluster. They're tasked with maintaining the control of the cluster if any node is to fail. Witness server. This is a really lightweight, it can even run, and most of our customers do run it on a VM. It's just a little Python module, a server that acts as the stretch cluster moderator. It has to be located at a third site in a two-failure domain cluster. It's not needed at all if you have 3 sites with Datera. So our customer requested a very simple stretch cluster across 2 fault domains. The sites in this case, New York City to New Jersey, are about 7 miles apart. They run a combination of mission critical. We've got SQL Server, we've got VMs, NoSQL, we've got a couple of containers running. They're mostly Tier 1 and Tier 2 workloads. Each failure domain has 6 Datera nodes. In this case, they're HPE DL380s. It's running on L3 networks, could be on L2 as well. The cross-site connection is a dedicated fiber channel link. This fiber channel link has about 3 milliseconds of round-trip time latency. We usually recommend anywhere between 1 to 20 milliseconds. This is synchronous replication, so there's no data loss. There's no recovery time required. We call this RTO, RPO 0, recovery time objective of 0. We can seamlessly survive the loss of an entire fault domain. The customer also uses SRM as their true DR solution. So this is high availability. If you want real disaster recovery, you want to protect and bring this into a third region. In their case, they bring it into Chicago. So true disaster recovery. So the customer's actual stretch cluster really only needed to comprise their Tier 1 workloads. Let's call this stretch cluster Datera 1. We've got Datera 2 in New York, Datera 3 in New Jersey. The cluster is actually only 100 terabytes, and it only has the Tier 1 workloads, so there's actually only 4 DL380s that we have in each cluster on each side. Each of those DL380s, by the way, some have Optane media, others have NVMe, they even have hybrid with rotational drives. So the media can be very different. It can be heterogeneous on either side of the cluster. The key is the cluster itself is 100 terabytes. This is synchronous replication from New York to New Jersey, and that cluster maintains with very high availability the Tier 1 workloads for this particular customer. I know I've made it look simple by drawing a bunch of boxes on a board. I want to walk you through in the Datera dashboard just how simple it is. and then we'll come back to me and we'll wrap this up and talk about why it's important for you. I thought I would take just a minute here to show you how simple it is to set up a stretch cluster with the Datera system. You need a minimum of 6 nodes and 2 failure domains. So let's go about getting that set up. This again is very simple. We've got 2 sites. We have 6 nodes. We enable stretch clusters. We put in the IP address of our witness server. We happen to have one set up at AWS, so I'm going to blur it out here. Insert the port number. We're going to keep all the defaults, so 5 minutes for our heartbeat, and we will then set up 2 fault domains. We could have called them Site 1, Site 2 in our example. We're going to call them Datera 2 and 3. Let's go ahead and define those. And select 3 nodes to add to it. This is Datera 2. And Datera 3. We've created 2 failure domains. We've placed 3 nodes in each. And believe it or not, you have already set up your first stretch cluster with the Datera system. I told you it was simple. As you've seen, stretch clusters with custom fault domains offer our Datera users the highest levels of data availability. You get very simple workload mobility and data center efficiency. As Bill also demonstrated, our fault domains are really quickly built via auto-aware topology scanning, and it lets Datera offer you node, rack, site-level fault domains. A Datera stretch cluster can be architected across a pretty wide geography or just across racks in the same data center. The workloads are intelligently routed within tiered nodes, and those nodes can use any combination of Intel Optane, NVMe, SSD, SATA flash, or even hard drive to meet your performance and cost needs. Very flexible QoS ensures that all your application SLAs are met, and these active clusters offer protection from any localized incidents. I want to thank those of you that have joined us for this video. We have links down below if you'd like to learn more, or if you'd like to test Datera in your own data center. We are here to help make that possible as well. Thank you.
Learn more about how Datera brings the software-defined revolution to enterprise storage at datera.io and contact Datera for a free consultation.